Okay, today we are doing properties of exponents. So we're going to review some here. All right, so the first one that we're going to review is a to the m times a to the n power. So let's see, did I mention that, so for our viewers at home, this is our first time videotaping third period. So I've been taping second period, but we're going to do a compare, contrast kind of a thing. So if you volunteer in class to answer a question, you kind of have to yell, like really give it a lot. Just project your voice as much as possible so that the mic picks it up. Okay? It's going to be kind of weird at first, but Zach?
I can't see the thing. Can we turn a light on so we can see the paper?
You can't see the paper?
Yeah, it's a little bit.
Can you? Oh. Is that better?
Oh, yes.
Okay. Cole. That's saying that we are recording right now. Ready? Okay.
Yes.
So that's good. Enthusiasm. I like that.
Yeah.
Okay. In fact, if there's any cheering that you all want to do.
Oh my God, yes!
Okay, here we go. A to the m times a to the n. Let's back up. So this should be a review from Algebra 1. If we have something like x squared times x cubed, how many people remember what you're supposed to do with the exponents? I won't call on you unless you want to be called on, but raise your hand if you have an idea about what to do with the exponents. Okay. Keep your hand raised if you'd like to say what you're supposed to do with the exponents. Tyler?
Multiply each x. Okay. Multiply the x the number of times the exponent says.
Okay. So what would if we were going to do that, what would our answer be here? It's x squared times x to the third power. That's x to the what? Okay, right, true. So how many do you end up with total when you multiply them? That's good, 5. Okay, so this is the one where you add the exponents together. 2 plus 3 is 5. So a to the m times a to the n is a to the m plus n. All right? Okay, next we have a to the m divided by a to the n. Okay, so think back again. I'm hoping this is kind of getting your brains working, reminding ourselves of Algebra 1 a little bit. If in this scenario we add the exponents together, try to think about what we do when we are dividing. Okay, raise your hand when you have an idea about what you're supposed to do when you're dividing exponential terms. Okay, keep it raised if you would like to volunteer what you're supposed to do with exponential terms. Sloan?
You subtract.
That's good. You subtract them. So a to the m minus n. So a more specific example, x to the 6th over x to the 2nd. X to the 6th over x to the 2nd is x to the what? Zach?
To the 4th.
That's good. X to the 4th. How are we doing on questions? Good? Okay. A to the m to the nth power. Again, everybody think back to Algebra 1. A to the m to the nth power. Thane?
You multiply the m and the n?
That's good, yes. You multiply the m and the n. So it's a to the m times n. So if we had something like x squared to the third power, x squared to the third, someone want to come up and write what you think this answer is? Come up and write. Aiden? Okay, so just keep it. The camera's right here.
Okay. Do I have to look at it while
I will narrate while you write down what. Unless you.
Okay. So.
Good. X to the 6th. How did you get x to the 6th?
I multiplied 2 or 3 by the 2.
Perfect. All right, everybody give Aiden a round of applause. Good. Okay, number 4. Next. All right. So the fourth one. Here, let me make sure you all can see that still. A to the m, b to the n, to the p power. Yeah. Okay. A to the m, b to the n, to the p power. To the n to the p. Okay. So this one is actually, it's really similar to the last one. The only difference is now we have two separate terms inside of the parentheses. So what we're going to do is we're going to take this exponent and we're going to distribute it to each of the terms inside. Okay, so we end up with a to the, what do we think? Alyssa?
A to the n times p.
Good.
And b to the n times p.
Good, you multiply still. Very nicely done. Okay, so an example here. 2x to the third to the fourth power. 2x to the third. I'm going to ask for another volunteer to come up and do this. Okay, so think about whether you would like to come up and do this. Try and think about how you would do it first. Okay. Alyssa, come on. So everybody actually be trying this while Alyssa comes up and see if you end up with the same thing, okay? And just remember you have to apply that exponent, actually, you have to apply that exponent to everything inside of those parentheses. So Alyssa is applying the 4 to everything inside of the parentheses. So she gets 2 to the 4th, x to the 12th. Excellent. Now, can we multiply out 2 to the 4th?
Yes.
Yes. 2 to the 4th is 2 times 2 times 2 times 2. That comes out to how much? 16. Good. Perfect.
Sorry.
Good. 16. Right. Good. No, you're good. You can see it. 16x to the 12th. Perfect. Everybody give Alyssa a round of applause. All right. All right. How are we doing on questions? Can I move this up, or are people still using it? You good? Okay. All right. Next idea is very similar to what we were just doing. So we have a to the m over b to the n to the p power. Okay, a to the m over b to the n to the p power. So this is the same exact idea as what we just did in the last one. The only difference, in fact, let me get that up here. The only difference is that instead of having two things being multiplied together inside the parentheses, they're divided. But we take the same exact approach by distributing that p. Okay? So does someone want to take a guess at what we end up with when we distribute this p? Again, same exact concept. The only difference is we have two things being divided instead of multiplied. Multiplied. Cole.
Okay, so would you get a
That's right.
Put the p in before you subtract, right?
Yeah, we're actually not even going to subtract in this one.
Really?
Mm-hmm.
Oh, okay.
The reason we're not going to subtract...
A in p over b in p.
Perfect. A to the MP over B to the NP. And that brings up a good point, actually. The reason, thank you, Cole, the reason that we're not going to do that is because they have different bases. This has a base of A. This has a base of B. So we can't combine them and do the whole subtraction thing. Okay? So let's do 2 over x cubed to the 4th power. 2 over x cubed to the 4th. So can somebody tell me, I'm going to have you guys come up a little bit and when we start our examples, which is in just a second, but can somebody tell me what you think this would come out to? If we're, again, just doing that whole distributing that 4 to what's in the parentheses. Olivia?
16 over x to the 12th.
Perfect. How did you get that? So she said 16 over x to the 12th.
I distributed the exponent to 2 and to x.
Perfect. So, whoops.
And multiplied 2 to the 4th power.
Perfect. So 2 to the 4th, she distributed that 4 to both the numerator and denominator and got 2 to the 4th, which is 16, and x to the 12th. Okay, how are we doing on questions, you guys? Good? Okay, let's go through some examples. So, if you would like to be on camera, this is your chance. Okay, here we go. We are multiplying or dividing and simplify. So the first one, 5 to the 6th times 5 to the 3rd. 5 to the 6th. So what I would like you guys to be doing as we go through these is look back at your notes to see if which rule each of these problems applies to. Okay, so everybody be looking at that. And the notes piece that I'm talking about is, like, the first page of our notes was this one. Okay, so see if this one looks similar to any of those. Okay, so raise your hand if you would like to come up and do this problem. Jiro, come on up. In fact, while Jiro's doing this, I'm going to put the next one up so people can see if they would like to do this one. 8 to the negative 6 times 8 squared. Okay, so people who are out there and good to go, just go and grab one of those buttons. See if you would like to do that one, okay? And while he's doing it up there, you guys can see if you've got the same thing. Perfect. 5 to the 9th. How many people got the same thing as Jiro? Awesome. For our audience at home, a lot of people in the audience raised their hand. They agree with him. Give Jiro a round of applause. Thank you, Jiro. Okay. Next one. 8 to the negative 6 times 8 squared. Olivia and then Thane, I'm going to get you on the next one, okay? So Thane, I'm going to put the next problem up here so you can see what it is first, okay? So this one's a little bit bigger. 5x squared y to the third times negative 6x to the fifth y to the ninth. Let me write it over. 5x squared y to the third times negative 6x to the fifth y to the ninth. Oops. So that's the one that you're doing, Thane. Okay? So go ahead and grab one of those. All right, so now we have Olivia. Olivia's doing 8 to the negative 6th times 8 squared. And you can talk while you're doing it if you want to.
Oh,
Otherwise, I narrate for you.
okay.
So are we adding these exponents or are we multiplying?
Adding.
That's good. How do you know you add?
Because they have the same base number.
Good, perfect. Okay, so go ahead and go for it. So everybody be thinking what you got as an answer and see if it ends up being the same thing as Olivia. Perfect. Excellent. Everybody give Olivia a round of applause. Okay. Yes.
I was just wondering how come we don't, why we did times 5 times 5 and 8 times 5, even though it was multiplied.
5 times 5 and 8 times 5.
I mean 8 times 8.
That's okay. So in all of these, so like, why did we not get 25 to the 9th or something? Okay, when you do this, what is this noise? I think I'm having an alert up here, and I don't know what it is. Did you guys hear that? Mm-hmm. Okay. So when you do the adding of the exponents, that takes care of the whole multiplying these together. So let me ask you a question, Sloan. So x times x gives us what? X squared. Good. Okay. It's like each of these has an invisible 1 there. And this kind of shows the whole, that property. Okay. If you were to multiply these together and add the exponents both, you'd be like doing double duty. So you would get x squared to the squared or something. So you don't want to overdo it. So the adding takes care of that. Vanessa.
Do we not like put a 1 over to like change the negative?
That's good. Okay, excellent. So, perfect. Vanessa said, do we not put a 1 over it and change the negative? You do. You do. Very good. So what does it become?
1 over 8 to the 4th.
Perfect. 1 over 8 to the 4th. Nicely done. Questions? You always want to do that if you end up with negative exponents. All right. You ready? I'm going to give you a different piece of paper so that you have plenty of room here, okay? So 5x squared y cubed negative 6x to the 5th y to the 9th. So the one thing I would ask for anyone who comes up here, just try to write big enough. So the size that I have it, or that's good, he's waving, yes. Okay, so try to write the same size or bigger. Okay, so go ahead and grab one of the buttons. So we have 5x squared y cubed. Somebody thinking about what you're supposed to do with this and see if what your idea is matches up with what Thane's idea is, and then we can analyze. All right, so what Thane is doing is 5 times negative 6. Okay, so what he's doing is he's combining the 5 times negative 6 together because those are the two big numbers. He's also doing x squared times x to the 5th because those have the same base. They both have the base of x. And he's combining the y cubed and y to the 9th because they have the same bases. Does that make sense? Okay, so let's see what he ends up getting. So 5 times negative 6 is negative 30. The x squared, x to the 5th, that comes out to x to the 7th. He added up the exponents. And then y cubed and y to the 9th is y to the 12th. Go ahead and put a box around your final answer. Is that your final answer? Okay, so put a box. That's good. So he got negative 30x to the 7th, y to the 12th. How many people agree with that? How many people got the same thing? Okay, for our audience at home, lots of people with their hands up. Okay, people who did not get that same answer, are there questions? Thank you, Thane. Everybody give Thane a round of applause. Are there questions? Questions? Okay, let me just write one thing. Squared y cubed. 5th y to the 9th. I like to use, I do color coding on these. So you multiply those together. 5 times negative 6, negative 30, exactly like Thane did. And then you do the ones that have the same bases. Put those together. Since you're multiplying two separate ones, you add the exponents. X squared times x to the 5th is x to the 7th, exactly like Thane had. And then y to the 3rd power times y to the 9th. Again, if you add those exponents, you get y to the 12th, exactly like he did. So he just showed his combining the same ones in a little bit of a different way, but same process. Questions? Yes?
So if you don't multiply like 5x squared times negative 6x squared, if you add it, is it still you're still adding the exponents too?
Right. You always add in this scenario, you add the exponents, multiply the big numbers. Right. Other questions? Okay. Here we go. Let's move on to a different property. You guys are fun to videotape with. I have to say.
Yes.
That's yes. Take that as a compliment. Okay. Let's see. 4. All right. Everybody be looking at this. 6 to the 8th over 6 to the 3rd. 6. I'm going to put the next couple up here. So you guys can be thinking about whether you want to come up here. 10 to the negative 3rd over 10 to the 6th. 6 to the... Whoop. Hold it. I come prepared. Okay. So 6 to the 8th over 6 to the 3rd, that's the first example. And then 10 to the negative 3rd over 10 to the 6th. Okay, do I have a volunteer who would like to come up and do the first one? Sloan, come on up. Everybody be looking at the second one to see if that's something that you think you'd like to do. Okay? Let's put these over to the side. There you are. Okay, so again, you guys be looking back at the notes and the properties that we've learned to see which one applies to this particular problem.
All right. I just wanted to write it over again, but no,
That's
it's
okay.
fine. It's fine.
So you can write, just make sure you write big.
Okay.
Like the same size, so that's the thing. So write the same size as what I have up there or bigger. Don't write smaller because you can't see it anymore at that point. So good. So 6 to the... Good. So what is it? That's 5, right?
Yeah.
Good.
Oh, sorry. All right, and then I just want to say.
Good. Perfect. So what she did is she just subtracted them. Excellent. Put a box around that 6 to the 5th. All right. Everybody give Sloan a round of applause. How many people agree with Sloan that 6 to the 5th is the correct answer, that you subtract them? Very good.
Yes.
Okay. How about 10 to the negative 3 over 10 to the 6th? What do we think? Is there anyone who would like to do that one? Have all three of you come up already? You have not. Okay, Tyler, come on up. Let me write this. I'll just go over this a little bit. 6 to the 5th power. So it's a little bit easier to see. There you go. Yeah. Okay.
Okay, I just had the answer in my head.
What does that say?
4.
So
10 to
negative.
4. Oh wait, I did it wrong. Never mind. I'm like having a brain fart right now.
Okay, that's okay.
There.
Whoops. 10. Good. Okay, so 10 to the 10 to the 3rd. Okay. Everybody give Tyler a round of applause. Thank you, Tyler. Now, how many people, let me do something here. How many people would agree with 10 to the 3rd power? Okay? How many people would disagree with 10 to the 3rd power? How many people don't know? How many people don't really care?
I want to get them wrong.
Okay.
It's cool. I've been teaching math for a while. I know how you all really feel. Okay, so I'm going to, how many people would agree that when you divide, you subtract the exponents? Would anybody agree with that? You subtract. So this would be -3 minus 6, correct? -3 minus 6. Remember the whole, if my day started out at a -3 and 6 more bad things happened, where would I end up? -9. So 10 to the -9th power. Okay. Which is 10 to the -9th over 1. So how would that be with a positive exponent? Aiden?
You flip it over.
Good. You flip it over. So it's 1 over 10 to the 9th. Okay, good. How are we doing on questions, you guys? Alyssa? Oh, no, that's thumbs up. Good. Okay.
So
Aiden?
you never multiply it out for your final answer. You just always leave it with the exponent.
Okay, yeah. So when you have humongous, I look at that as being a pretty big number. You don't have to multiply that out. This one is also relatively big. If you get something like 2 to the 5th power, that's decent. So, but yeah. Go ahead.
On homework, we still leave it as an exponent, but you say it as a multiplied out number.
Yeah, that's you. I will distinguish the two, and yeah. Sloan.
While doing our homework tonight, if we come across a negative exponent, you want us to make a positive,
Yes,
right?
right.
So never leave it just
Right.
to negative.
Right, exactly. So fully simplified means you do not have negative exponents, so you always want to get rid of them. Other questions? All right, we only have a few more. Cole? Okay, you got to yell it. So like 10 divided by 10 would be 1. Okay. When you do this whole, here, let me actually, what if I have something like x to the 5th over x squared? If we were to use that logic, we would end up with, well, x divided by x is 1, right? So 1 to the 3rd power. But here's the problem with that. Would you agree that x to the 5th, let's see if you can see that, x to the 5th is the same thing as x times x times x 5 times? Is that true? Okay, and x squared is x times x. Okay, and what you can do is you can go through and cross out repeating x's in the numerator and denominator. What are you left over with? 3 x's, yeah. If you cross out the x's, then if you follow that logic, you're in all of these going to end up with 1 to some power because all of them have, does that make sense? Exactly. No matter what, you leave the base as whatever it started out to be. Other questions? Okay, let's move on. So number 6, make sure you all can see. All right, -24x to the 6th y to the 7th over 18x to the -3rd y to the 9th. So there are already videos posted online. These will be posted on today, by the end of the day. So if you guys get home and need help with your homework and you couldn't remember quite what we said in class, guess what? You can watch class again. Isn't that awesome? Okay. Whoa. That's the whole point of them. Okay. Here we go. -24. We're just going to do this one as a group here. Okay, so -24x to the 6th y to the 7th times 18x to the -3rd y to the 9th. Okay. First thing that we want to do here. Any suggestions? Alyssa. Yeah. Perfect. So what she said is divide those numbers, or if we can't divide them, reduce them. That is perfect. So can you guys think of a number that both 24 and 18 are divisible by? Alan, right?
Yeah.
Go for it.
6.
6. Perfect. So we can divide by 6. Nicely done. So Alan, when we divide by 6, 24 divided by 6 is what?
-4.
Excellent. Next, we want to do the same thing that we did with the other problems. If they have the same base, combine them. Cole? Okay, right. The only time that you don't follow the rule that you were saying is if you have just numbers by themselves. With numbers that are by themselves with no exponents on them, you do this. Reduce it. Okay? Other questions? Okay. X to the 6th divided by x to the negative 3rd. Remember you all told me that means subtraction, right? 6 minus negative 3. How many people agree that that's 3? 6 minus negative 3. How many people agree that 6 minus 3 is 3? How many people agree that... Okay, wait. Let's erase all of that. Okay, how many people agree that 6 minus 3 is 3? That's true. Okay. How many people agree that 6 plus 3 is 9? How many people are not sure whether this means 6 minus 3 or 6 plus 3? Anybody? We're all sure, one way or the other. Okay, would you guys agree that 6 and then the negative 3 turns out to be this? Is that true? If we're subtracting? Okay, what happens to a negative right next to a negative? Positive. So this becomes 6 plus 3 plus, which is what? 9. So it's x to the 9th. Okay. How many people are doing something fun this weekend? Anybody?
I don't even know what I did.
How many people have a lot of homework to do this weekend? And how many people feel like that's kind of a bummer? Anybody? Yeah. So when I was in college, I had this pattern. So I would totally take Friday night and Saturday off completely. No work of any kind. And then Sunday was my homework day. I would do all my homework on Sunday. And then I bothered all of my TAs. They got really tired of me by the end of my college years. I would actually go into some of my classes where I had no idea what was going on. And I would go in, I would be like, I don't even know where to begin. I'm so lost. And those poor, they had to sit there and tutor me for 2 hours at a time. I barely, I got my C minuses in those classes and I moved on and I was happy with that. Some classes don't work well for me, but all right, here we go. Y to the 7th over y to the 9th. That's a subtraction, so that comes out to, everybody show me on your fingers, 7 minus 9. Positive is up this way, negative is this way. If you have 7 minus 9, that comes out to what? So a lot of people are going like this. Good, okay. 7 minus 9, that's negative 2, so we have y to the negative 2nd power. Can we leave it as y to the negative 2nd?
No.
What do we have to do? That's good. We have to move it so that it's no longer a negative exponent. To do that, we move it to the opposite side. So who can tell me what the final answer to this one is? The whole answer. Aiden.
Negative 4x to the 9.
Good.
3y to the 2nd.
Excellent. All right, how are we doing on questions? All right, I need 2 more volunteers to come up and do problems. So, you might want to see them first. These are some really atrocious, scary problems. Okay. Okay, 4/3 to the 2nd power. In case you hadn't noticed, I'm a little bit sarcastic sometimes.
Wow.
Oh, it all makes sense now. Okay. 6 to the negative 4th. Okay, so everybody look at these. Whoop, they're down a little far. Let's move them up. 4/3 to the 2nd power and 6 to the negative 4th to the negative 3rd power. So, raise your hand if you would like to come up and do one of these problems. Put your hand down if you have already come up. Sorry. All right, Cole, you get number 1. Alan, you get number 2. So, Cole, come on up. And after this, we have one more example problem, and then we're done. Let me go ahead and stick that one up here for those people who would like to get a head start. Y to the negative 4th to the negative 2nd. That's the 3rd one. Best handwriting you got.
Oh, no. Right. All right. Which one? Number 1, right?
That's true, yes. I had the privilege of having Cole in my class last year.
Privilege, right.
Yes. Excellent. 4 to the 6th power. How many people agree with Cole? For our viewers at home, our audience is a little unsure. How many people agree with Cole? That's a hint. Cole is right. Everybody give Cole a round of applause. Thank you. Okay. And Alan, come on up and do the second one. So that would be a 4 to the 6th power you multiply. Perfect. So the next we have 6 to the negative 4th to the negative 3rd power. Perfect. So he's doing 6 to the negative 4 times negative 3. That's perfect, which is 6 to the 12th power. How many people agree with Alan?
I do.
Alan agrees with himself. Give him a round of applause for agreeing with himself. That's good. You want to be sure of what you're doing in life. That's a good thing. Okay. All right. How are we doing on questions? Aiden.
So the first one is 4 to the 3rd parentheses times negative 2.
Oh, no, that's not. I don't. It looks like negative 2 up here. It's not. It's supposed to be positive 2.
Okay.
There we go. My pen must have. Okay. All right. Let's just go through this one as a group. Negative 2x cubed y to the negative 4th to the negative 2nd. So this one is a direct example of one of the last properties that we learned, where we're going to distribute this negative 2 to everything in the parentheses. All right. So when we do that, shh, Cole, you had your moment to shine still. Pay attention. Okay, negative 2 to the negative 2. Now, what happens with these? I do what with the exponents here? That's good. Multiply. So 3 times negative 2 is? That's 3 times negative 2 is?
I mean, 6.
That's good. Positive or negative? That's negative 6. Okay. Negative 4 times negative 2? Positive 8. Excellent. Now, we've got some negative exponents, which means we don't want them there. How do I get rid of the ones that have negative exponents? How do I make them positive? Good. Perfect. Sloan said flip them to the bottom. That is exactly right. Down to the bottom. So I get, whoops. All right. So I get, who can tell me what I end up with here? Sloan, go ahead.
Y to the 8th power of,
That's right.
yeah.
This is the top
over
still.
Negative 2 squared
Uh-huh.
x to the 6th.
Perfect. And then, what is negative 2 squared? 4. 4x to the 6th. Okay, you guys, how are we doing on questions? Michael's had a question? Okay. Any other questions? Comments? Okay. Let me go ahead and put what your homework assignment is up here so you guys can all get going on that. You guys have about 10 minutes left, I believe. I think that's what time we get out here. All right, homework number 4. This is, let's do this. Homework number 4 is page 42, numbers 6 through 66 all. Just kidding. Multiples of 6.
I was like,
Multiples of 6. You have 11 problems. Some of them can be...
that wasn't
Yeah.
funny.
Oh, you know it was. Okay, so everybody get out a textbook and start on the homework assignment right now. I'm going to leave this up for a little bit so you guys can still write it down, but everybody get out a textbook. You have lots of time to ask lots of questions. Use it wisely.